Today I'm going to talk about support vector machines or SVM. The first thing that we have to know about support vector machines is that they are supervised learning. So we already give the labels, so we know what the labels are. We know what the answer actually is. So another thing to consider here is that support vector machine is for classifying. So it's, for example, something is or not, 1 or 0, true or false, cat or dog. So these are the things that support vector machine can figure out. So it's not like, even though it is like a line like in linear regression, but it is not used for it is not used for continuous data. It is used for labeled data that is for classification, as I said, like true or false or things like that. So first let's look at SVM in one dimension, and then step by step we're gonna go forward and see how it looks in other dimensions. I have one dimensional data set, and then my data points, I have red data points here, and then I have green data points here. So this is very easy. This is very easy to separate. All I have to do is to find a point that is right in between these two points. That point, I would say, is here. How did I find this point and make sure that it is in the middle? It's because I have a margin here, and I'm using this. I'm taking this point, that is the last data point, as my support vector. So that means that it will support, it will tell where this margin is supposed to go. Our margin is going to be close to our support vector, which this point toward the end is the support vector. And then again, the same thing happens here. The last point is this red point, and that's going to be my support vector, and I'm going to draw another margin here. This distance is the same as this distance. So this is basically what SVM is. Now you see this. What would be a problem if our line is not going to be in the middle? If our line is not exactly in the middle, this is what's going to happen. So for example, I have another line. I'm going to have one axis, and then I'm going to have these data points that are here again, and then I have these red points that are here. Okay, and then what's going to happen is that I'm going to say I don't care that my separation line be exactly in the middle. I'm going to put, for example, my separation line here. So right now, if I have a point, if I have a red point here, it is fine. It is going to say, okay, this is a red point. But then, for example, if I have a point here, I don't know what this point is, okay? But my model is going to predict this. As green, okay? But green points start from here. This point is very close to red point, so the chances are it is probably a red point, right? But then since you put your separation line here, you cannot recognize, you will still say that this is a green point. We looked at this VM in one dimension, and it was very easy to understand, okay? But our data in real life is not going to be like this. It could be. So now I'm looking at this, and I cannot draw any line that can separate red and green from each other, because we just need one line, okay? Because these are the same thing, these are the same thing too. You don't want to divide it in 3 different things. You want to divide it in 2 different things, and it's not happening right now because it's not linear. at this dimension, I cannot have a linear line that is going to separate these two from each other. So what's going to happen is that I'm going to add another dimension here, because my support vector, sorry, my line have to be a linear line, and I cannot do a linear line here. So what I can do is I'm going to add another vector. We talked about polynomials. We're going to add another vector. So when we are taking it to the higher dimension, it's going to be separable. I'm going to show you what I mean by that. I'm going to add another dimension to this data set, and that is going to be, for example, this is my x. These points are my x. And then for y, I'm going to do x2. You can do anything that would make sense for your data set. It's not supposed to be x to the power of 2. It can be anything that is going to be meaningful to your data set. No, they're not supposed to be linear. So how do we show that they're Okay, so hold on. I'm going to draw a line like this. And then this line does not exist. I just want to make sure it is easier for me to put the data. I mean, if you want to show your data is a continuous, like you can choose any of these points on top of this curve, you can, but that line does not exist. Just keep in mind. Don't get confused there. And then I have these green dots here. And then I have these red ones here. Okay, so now I actually can draw a line. So now I can draw, let's see how well I can do this. I can draw a line here. Okay, but you see what I mean here, right? So this line is linear. When we added another dimension, then it is linearly separable, okay? But then imagine, okay, let me show you from another point of view so you can see actually what happens, because we say SVM is linear, and then sometimes you look at it and say, well, why there's a circle then? You said it's linear. That is because you did it in higher dimension, you separate them from in a higher dimension, and then you bring it to a lower dimension. If you remember, this sounds very much like kernel, because kernels don't actually take your data point to a higher dimension, but what they do is they calculate that if your data was going to the higher dimension, this is going to be their relationship with each other. And that way you can draw a curved line, but it is actually a line in a higher dimension. And I'm going to show you how. So if I have a plane here like this, okay, imagine this is just a plane. I have these red dots in the middle, and then I have these green dots around them. And then I use kernel, and what I do, I said SVM is a line, is a linear line, but I'm looking at it and I see that there is a circle. Okay, I'm saying, well, that is a circle. That is not actually a line. But let's look at it from another dimension, and then you will see that it is actually a line. So, okay, so if I want to look at it this way, so right now you have all of your data points. You're looking at it from the top. Imagine this is like a plane that we are looking at it from the top, and we see all of these data points. Now I'm going to give it another dimension, which is, now it is like a box or something, right? Okay, so now when I look at it from there, these red points are not here anymore, but these red points are here. And then those green dots are above there. So let me just remove these. okay? So basically what I did here right now, since those red points are down there and then the green points are up here, right now I can draw not a line but a plane, okay? Plane, but it is a linear plane. I can draw a plane here. Ooh, this got very confusing, didn't it? No, okay. This is getting too confusing. I'm sure you're getting my point. I think I'm not very good at drawing. Okay, yeah, so basically anything that I put extra here is going to be very, okay, yeah, that works. Um, so yeah, those green dots are up there, and these red dots are on there, okay? And we have this sheet that is separating these red dots from green dots, okay? But then when you're looking at it from the above, you will see that these red dots are separated from those green ones, okay? And the way that we are separating, when we are looking at it, we're separating it like that, is to create this circle around it, right? But actually, when you're taking in the higher dimension, the red dots are actually down there and the green dots are up there. And the reason that kernel works here is because we already know the label. So we know which ones are red, we know which ones are green. So what we do, we're looking at it and we're trying to find a mathematic relationship between them, like a mathematic relationship. If it is separable with x to the power of 2, we will do that. Which mathematical technique or model is able to separate these two from each other, and we will choose it that way. It's not that oh, how did you know x to the power of 2 is going to solve this problem. It's because I already have the label. I already know which one is red and which one is green. So based on the knowledge that I have, I know that I have to be able to separate red from green. And with that knowledge, I'm able to predict the data that I haven't seen, because I already figured out what it is. From those labeled data, I understood how I can separate them. That doesn't mean that 100% of the time is going to be correct, but that's basically what it is. Majority. It depends. Your model might have overfit or underfit. So many stuff might happen, but if you have a proper model, that's what you're supposed to get. Like the chances of that being green should be high. Okay, let's look at another data set. For example, I have again two-dimensional data set. This is an actual two-dimension. I'm not creating one dimension. So I have x and I have y. Okay, and then I have, for example, for this one, if I draw a line like this, I can still separate these two. Your margin lines are going to be small, and we said we want the maximum margin line. So we want the maximum space between the margin lines, and the line has to be in center. So this is not the best way, obviously. I'm going to make the line look like this. So now my margins can go all the way there. I mean, it's not exactly in the middle, but you're getting the point, right? So if I put it this way, the margins are going to be very close to each other. I can do it again, like here. So like this area is different from this area. See? Even though this line can separate these 2 points, but this is the ideal line.